Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver. We're going to be talking about 6.1 today, which is the binomial probability distribution. We have a lot to talk about, so let's get started. First of all, from your last reading, you were supposed to remember the four main requirements. I kind of merged them into three for a binomial experiment. Okay, a binomial, bi, is a prefix for two. That's why they use the binomial. It means two outcomes. That is the most important thing about a binomial experiment. When you go out and run a trial, you're going to record either a success or a failure, which can sometimes be called a yes or a no. So that's the main key about a binomial. The other thing is that I'm writing independence, but specifically the probability of getting a success in each trial is the same. That means independence. When probabilities don't change, we have what's called independence. So the key thing in number 2 is that the probability of success for each trial is the same. And then 3, the last requirement for a binomial experiment is that we have a fixed number of trials. So meaning you don't keep running this experiment over and over until you find something. You determine that you're going to run, say, 10 trials, or survey 15 people, or observe 15 trains and see if they're late or not. Okay, so you have to remember these three main things, but it's pretty simple. Binomial means usually success or failure and the same probability each trial. So when we do this, it's really important, it's really important in a binomial experiment to know these three parameters here in green. N is the number of trials, okay? And that's usually like if you survey 10 trains, then N is 10, or if you run an experiment 10 times, then N is 10. So that should be pretty clear what N is. P is the probability of success, or a yes I'm putting there, okay? And X is the number of successes, or yeses, from N trials. So usually X can be anywhere from 0 to N, all right? So sometimes when you run an experiment N times, you get 0 successes, or 1 success, or 2 success, or 3 success, all the way up to N. Alright, now let me draw this back to the example from the last exam. There was a question that said 18% of all students, this is in blue now, 18% of all students find Spence funny. If we decide to survey 4 students and record the number who find Spence funny, this is a binomial experiment. Why? Well, it's pretty simple. When we do this, I'm going to check off the requirements. If we go out and ask people if they find Spence funny, that's a yes or no question, so we have 2 outcomes. All right. We're also given independence because if somebody says yes, if somebody answers yes to this question, it's not going to influence the probability that somebody else is going to say yes or no. So we have that. So the probability of anybody saying yes, Spence is funny is 18%. And then finally, it's a fixed number of trials. Well, what is our number of trials? In this case, it's 4. We're surveying 4 students. So in this case, in our problem, we realize that we have a binomial experiment. Down here in orange in the lower right-hand corner is the beginning of the table, which is going to be the binomial probability distribution for this. In class, we talked about, and from the last test, we should be able to figure out the probability of 0 and 4. 4 means that all 4 people said yes to this question, 4 in a row. Well, the chance that one person says yes is 0.18. And if we raise that to the 4th, that's 4 people in a row saying yes to this question. If we take 0.18 to the 4th, we get 0.0010. 0.0010, and I ran out of room there, but hopefully you can see that. Okay, and then 0, the outcome of 0 is that none of the people find me funny. Well, that means that we get 4 no's in a row, and the chance of getting a no the first time is 0.82. But if we want, 0.82, excuse me there, let me fix that. And if we need 4 in a row, then we take 0.82 to the 4th, and we get 0.4521. All right. Then the rest of the last classwork was talking about figuring out the probabilities for 1, 2, and 3, and that's what we're going to do on the next page. Okay, so now we're going to show you how to figure out the probabilities of these 3 other outcomes, 1, 2, and 3. Now mind you, when we did 0 and 4, let's look at 4 for instance, when we look at that outcome. 4 means that Actually, I think I have these probabilities backwards. Let me check really quick. Yeah, I'm sorry. Let me pause this and fix. Okay, excuse my error. I made a couple corrections to the table. So when we look at the probability of, or the outcome of 4, that means 4 people say yes to this question. Yes, Spence is funny. And that is shown here. 4 yeses. 1, 2, 3, 4. And there's only one way that can happen. So when we do the probability, it's pretty simple. We just take 0.18 to the 4th and we get 0.0010. But now we're going to do the outcome of 1. And what's more complicated about 1, 2, and 3 is that there's multiple arrangements of having 1 yes out of 4. So for instance, if I was going to put 1 yes out of 4, I might do yes, no, no, no. I might do no, no, yes, no, no. I could do no, no, yes, no. And I could do no, 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 yes. So we can all agree that there's 4 ways that can happen. Alright? But what's interesting is that if we look at the probability of each of these ways that it happened, they're all the same. Because really there's 1 yes, which has an 18% chance of happening, and 3 no's. So 0.82 to the 3rd. No matter what, in any of these arrangements, you're multiplying 0.82 3 times, and you're multiplying 0.18 1 time. Well, if you multiply those together, 0.18 times 0.82 to the 3rd, 0.18 times 0.82 to the 3rd, you should get 0992. 0.0992. But that's not the probability of 1, because that's the probability of one of the ways that 1 can happen. And there's 4 different ways, and they're all the same. So to figure out the probability of 1, since there's 4 different ways it can happen, we take 4 times the 0.0992, and that gives us 0.0992 times 4, 0.3968. And that's the probability that goes right here, 0.3968. Okay? So this is the beginning of showing you what the binomial formula is actually going to do for us. All right, when we figure this out, we're figuring out an outcome in a binomial experiment, 1 out of 4 yeses. So remember, back to the previous page, every binomial experiment has a number of trials, a probability of success, and a certain number of successes that we're concerned about. For this problem that I just did for 1, remember, how many trials are there for this experiment? Well, we asked 4 people, so n would be 4. What's the probability of success or saying yes to this question? Well, it was 18%, so p would be the 0.18. And in this case, we're asking for x equal to 1. We found the probability of that outcome, and the 2 other outcomes, 2 and 3, can be done the same way, where you list out how many different organizations you can have of yeses and nos for 2. How many different organizations of 2 yeses and 2 nos. That would be this one. And there will be 6 ways, so keep that in mind. And then the organization of 3 yeses and 1 no. There's 4 of those, and you figure out all those probabilities that way. What's nice is that in the future, we won't have to do all this organization of yeses and nos or successes or failures. Because a lot of times we're going to be doing more than just 4 trials for an experiment. We might want to do 20 trials. And when we start to organize yeses and nos for 20 trials, it becomes very overwhelming. So I'm about to show you what we're going to do using the binomial formula on the next page. So now we have the binomial formula in front of us. You're going to see this in the book. And what this is a formula for figuring out the probability of x successes. That's why we have x right here. Now remember, we just did 1. We did x equal to 1 on the back page. Remember, right there, we found x probability of 1. And let me just explain this formula, how we did it, okay? Oops, that's not 11. That's supposed to be 1. Okay. So what it does is the first part of the formula tells you how many ways this can happen. That's your math, the math notation here. You see n, c, x. It's called n choose x. And that tells you how many ways you can have X successes organized out of N trials. Remember, we found that to be 4. Remember, we did the organizations right here. There were 4 different ways we could get 1 yes out of 4. Then we took it times the probability. P is represented by the probability of success, remember. Probability of success, or somebody saying yes to this question, is 0.18. 0.18. And how many successes did we want? That's X, right? 1 success. And then we multiplied that, the 1 minus P, well, that's your 0.82. That's the probability of a no or a failure. So 0.82 and to the power of 3. 4 minus 1 up there is 3 because N is 4 and X is 1. And that gives us our answer that we found back here, 0.3968. We just did that. However, there's a way to do it in the calculator. The way to do this formula in the calculator, and this is what we're primarily going to be doing. So this is where you need to pay attention, calculator. All right. To find this function, we do second, and then the button vars. And the vars button is near the arrow keys, the upright left down arrow keys. It's actually right next to the button clear. If you do second vars and you scroll down far enough, you're going to find the binom PDF, which is the binom probability density function, which is this formula. This is the binom PDF. Okay? And the calculator will always want you to give it 3 things, N, P, and X. Well, in our problem, remember the binom PDF, the one that we just did, our N was 4 because we did 4 trials. We asked 4 people. The probability of success was 18%. That's the probability that they find Spence funny. And then we wanted to know 1 success. So if I do second vars, scroll down all the way down until I find binom PDF, press enter, and then I choose 4, comma, and remember the comma button is above the number 7, 0.18, comma, 1, press enter, and I'll get my answer just like that, the 0.3969, which would round up to 0.70 based on the 5th digit, and you can see that right there. It's really close to what we got. There's just a little rounding error from my answer previously, but we're going to start learning to use this binom PDF, and that's going to be a big thing. Instead of doing the formula and writing out how many ways you can get yes or certain number of yeses out of the total, it takes too long to do that, so we're going to use this formula for the future. And that's pretty much a wrap-up of what 6.2 is about. There's a few things later on that show you how to do the mean and the standard deviation, which we'll do in our classwork, but this is the main part of 6.1.